In this lecture we're going to discuss area of two-dimensional figures and then surface area of three-dimensional figures. I think you'll find it fairly simple and probably a review of many things you've learned in the past. If you look at the diagram here, and if I ask you how many square units were in that rectangle, you could go ahead and count each square and you'd come up with 32, or you might just remember that area of a rectangle is base times height or length times width. And since this width or height is 4 and this length is 8, you could just take 8 times 4 to get an area for the rectangle of 32 square units, or units squared. Now you can see that what I did was I cut that rectangle in half with a line from one vertex up to the opposite vertex, which is called a diagonal, and it leaves us with a dark orange triangle on the bottom. And if I ask what the area of that triangle is, I bet you agree you'd just take half of 32, which is 16. And that's where the formula for the area of a triangle comes from. That's a good visual of it. The area of a triangle is simply half of the base times height, or another way to think of it is the base times height divided by 2. Now, what is the base and the height of a triangle? You have to realize the base and height of a triangle have to meet at a 90-degree angle. So the base would be 8, the height would be 4. 8 times 4 is 32, half of that is 16. So the area of this triangle is 1/2 times 8 times 4, or 8 times 4 divided by 2, which is 16 square units. Now, remember what I just said a second ago, the base and height have to meet at a 90-degree angle. On this particular triangle, there is no 90-degree angle formed on any of these vertices or the angles in the triangle here. So what you had to do is, if we call this 15 feet the base, we have to extend that base out and then come straight up to the opposite vertex from the base to get my height. So just keep in mind that the base and height have to be at 90 degrees. They have to meet at 90-degree angles. So the 15 is my base, the 8 is my height, and we're ignoring that 20 right there. It has nothing to do with finding the area. So the area of this particular triangle would simply be 1/2 of 8 times 15, or 15 times 8. So that'd be 1/2 of 120, which is 60. And the units here are feet, so there's 100 square feet, 60 square feet, or you could say 60 feet squared. Either way, they both mean the same thing. Don't do this. I see students do this all the time. They put 60 squared feet like that. Well, that would mean 60 times 60, which is 3,600 feet. So don't write it like that. Write it one of the other two ways. Okay, here's a nice green lawn. Kyla's rectangular backyard has an area of 2,240 square feet. The width of her backyard is 28 feet. What's the length? Well, we know that the formula for the area of the rectangle is area equals base times height, or length times width. Since we use the words length and width in this problem, we'll use LW for length times width. And it says the area is 2,240. And we want to know the length, so we don't know that, but we do know the width is 28. So there's our problem. 2,240 equals L times 28. So to find that length, we'd want to divide both sides of that equation by 28 to get the L by itself. So L would equal, and let's grab the calculator here, we want to take 2,240 and divide it by 28. So the the length would be 80 feet. Let's see, did I lose my pen? Yep. So the length of that lawn is 80 feet. That's just an example of using the formula A equals LW and solving for a variable. Okay, this is just a quick reminder what the formulas are for the area and circumference of a circle. So the formula for area of a circle is pi r squared, and the formula for circumference of a circle is 2 pi r. So let's find the area of this circle with a radius. This is a radius of 8 centimeters. the area is simply going to be pi times the radius, which is 8 squared. Well, 8 squared is 64, so we have to take 64 times pi. So 64 pi is my exact area, and if we want to know an approximate area, we would take 64 times pi. So let's grab our calculator again, and let's take 64 times, and then the pi button on this calculator is right over here. 64 times pi is 201.06. 201.06. And this is the labels in centimeters, so since we're finding area, it'd be the number of square centimeters, so it's approximately equal to 201.06 centimeters squared. The circumference means how far is it from here all along the outside edge of the circle. What's the distance around the circle? That's what circumference is. Well, it's 2 times pi times the radius, which is 8. 2 times 8 is 16, so the answer to this is 16 pi. That's the exact answer. The approximate answer is whatever 16 times pi is. And remember, pi is irrational. It goes on into infinity. So we take 16 times pi, and then we'll just round our answer here. So we get 50.27 if we round that. So I just wanted to remind you what the formulas were, and this is just in centimeters. It's 50.27 centimeters around that circle. Okay, quick review for the area of a trapezoid. The formula for an area of a trapezoid is also something you maybe have seen before but maybe have forgotten. You add up the two bases, base 1 plus base 2, and these are the two bases, they're the parallel sides, and you divide that by 2 to average them out, and then you take that answer times the height. So in this particular trapezoid, you're taking 6 plus 10, you're dividing that by 2, and you're going to multiply that answer times 7 to give us 16 divided by 2 is 8, so we're going to take 8 times 7 to give us 56 square inches, or inches squared. You'll be using some of those formulas on MyMathLab, the ones I just showed you. You might also run into some problems where you have to find the area of some different looking figures where you have to use sub-problems. So if you were supposed to find the area of this green figure, maybe you'd want to split it into a rectangle, a triangle, and then another rectangle. Or you might want to split it like we did over in this diagram, or possibly just find the area of this entire big red rectangle and subtract out the area of the white triangle. So use your creativity to solve problems where you have to use sub-problems. So if we were supposed to find the area of this figure, I bet maybe the quickest way to do this is I'm going to draw a dotted line right here, and let's find the area of this big rectangle here. Well, that's 18 for the base, and we have 3 plus 9 plus 3. That's going to give us 15 for the height. So we're going to take 18 times 15, and I believe that gives us 270, and we're going to subtract from that this square, or that rectangle, which is a 9 by 10 rectangle. 9 times 10 is 90, and we're going to subtract 270 minus 90 to give us 180, and that would be in square inches. So we used a little creativity there to find that. Maybe you would have done it by finding that, finding the area of that, and finding the area of that, and then adding the three together. That would be fine too. Okay, now we're going to talk about three-dimensional figures. Surface area. Don't try to memorize formulas for this. Just use common sense. To find the surface area, find the surface, the area of each surface. So this Kleenex box, or it's called a rectangular prism, has 6 faces. So if we look at this diagram here, the area of this front is 10 inches squared, and there's also a back that's also 10 inches squared. Okay, the area of this side would be 10 by 2, which is 20. So to that we'd add 20, and then we have another 20 right over here. So now we just have the top and bottom left. So the area of the top is 10 by 5, so we have 50 on top and 50 on the bottom. So you'd combine all those together. Let's see, that'd be 140, 160. 160 square inches would be the surface area of that rectangular prism. Okay, what if we had to find the surface area of this chunk of cheese, and we're going to ignore the holes on it? Well, we're just going to have to find the area of the top, the bottom, and then the three sides. So the top is a triangle, and remember, base and height have to meet at a right angle. Well, here's our right angle right here. So we have a base of 10 and a height of 12. So we take 10 times 12 and we take half of that. So we're going to divide it by 2. 10 times 12 is 120, divided by 2 is 60. So my top 60 and my bottom's also 60. And then this side right here is 8 by 13. 8 times 13 I believe is 104. And the side opposite of that is also an 8 by 13 side, which is 104. And then we have a back side to the cheese, which is 10 by 8. We have a back that we can't see back here. That's 10 by 8 rectangle, which is 80. And then you just add all that up to find the surface area of that cheese. Okay. Here's the surface area formula for, I want to go back to the cheese for just a second. If we didn't include the area of the top and the bottom, then that's called the lateral surface area. So lateral surface area is the surface area without counting the top and the bottom, or the base and the opposite side of the base. So just if you run into those problems on MyMathLab, keep that in mind. If I ask you to find the surface area of a cylinder, and we're almost done here, let's do this. Let's take this can opener and cut the top off, and we'd have a circle. Well, the area of that circle is pi r squared, right? Then we'd cut the bottom off down here, and we'd have another circle, which is the area of pi r squared. So we have 2 pi r squareds. That's where that comes from. Then take these tin snips and cut this and spread it out, and aren't we going to just have a rectangle? And this distance would be the same as this distance right here, and that is the circumference, which is 2 pi r, and then this distance right here is our height. So to find the area of that rectangle would be 2 pi r times h, so that's where that part of the formula comes from. So to find the area of a surface area of a cylinder, you'd use that formula right there, 2 pi r squared plus 2 pi r h. That'll be handy doing your problems on MyMathLab and taking the Chapter 10 test or the Module 4 test. Okay, let's find the surface area of this water heater if the diameter is 2. So if this diameter is 2, that means our radius is 1, because the radius is half of the diameter. And it says the height is 5 feet. So we have 5 feet for the height, a radius of 1 foot. So we're going to go 2 times pi times radius squared plus 2 times pi times radius times height. 1 squared is 1. So 1 squared is 1 times pi times 2. That just gives me 2 pi plus my 5 times my 2 is 10 times pi is 10 pi. 2 pi plus 10 pi is 12 pi. So my exact area is 12 pi, which doesn't make a whole lot of sense thinking of it that way. So let's find the the approximate surface area by taking 12 times pi. And this answer would be, especially if you had to like paint it or something like that, 37.7. 37.7. So this has a surface area of 37.7 approximately. I should have approximately equal to 37.7 square feet. The next lecture will be on volume. So we'll be talking about how much water would that water heater hold, not what is the square footage on the outside. Okay, that's it for this one. Good luck on your MyMathLab, and thanks for watching. Bye.